Welcome everybody to a quick start guide on using SkyCiv Structural 3D. So we've broken these videos into a few different segments, starting from the UI into modeling, and then we look at some solving processes, design, and even how to share your files and collaborate with other team members. But the first video is just going to introduce you to the user interface. So when you open up S3D for the first time, it does offer you three options, and depending on your workflow, you can either open up an existing project that you've been working on, you can add a template, which we provide a series of easy templates to get started with that you can search through, or you can also import from another file format such as DXF, DWG, or even a Revit model. You can import them directly into Structural 3D. But for today's purposes, we're going to go through how to actually model in the software. So to start with a clean slate, I'm just going to click out of that window, and this is our main interface. So we've really tried to redesign the user interface to make it as clear and intuitive and fast for our engineers to work with. So everything is clearly labeled, and there really isn't much of an onboarding or a learning curve because the software is designed to be intuitive. So we've got our structural elements here, all clearly labeled, loading functionality here as well, and then you've got your typical file save and taskbar options. We do have some settings, so if you want to change your unit system, you can control them here, as well as some view settings and solver settings, and some other options to do with mouse sensitivity and graphic interactions. And then on our right, we have some visibility settings that they'll appear more as the video progresses, but you can toggle on different elements such as nodes or members, whether you want to see or hide those. And a live chat window here available for our professional users to get quick and easy support on your models and our software. So that's just a quick introduction to the user interface. Next, we're going to move on to modeling and looking at how we can build a structure using SkyCiv Structural 3D. Okay, so in this video we're going to look at modeling. We're going to be focusing on adding nodes, members, plates, supports, how to assign sections, and how to apply loads and load combinations to our model in order to get it ready to solve. And we're going to pay specific attention to the features and functionality that really make this process a lot faster. So really knowing how to master these features will drastically improve your modeling speed and allow you to work more efficiently. So we're going to pay close attention to some of those features and functions that help you model a lot quicker. So generally when modeling, I like to focus on nodes to begin with. Nodes are going to be the start and end points of all of our members, as well as key points of interest such as where we apply our supports, the boundary boxes of our plates, or even where you can apply point loads and connect members to each other. So I can enter nodes through this left menu where I can just tap and enter. So I'm just entering in the XYZ coordinates of the different nodes, so you can do it quite quickly on the left menu. But we do have features such as the data sheet, which allows you to copy and paste and change nodes and different values much more quickly by just copying and pasting and dragging down, much like an Excel spreadsheet. So you can also copy and paste from Excel directly into this data sheet. So if you do have some templates or some spreadsheets that you do use, you can easily import them by copying and pasting. So you can add nodes in that way, but you can sort of see that the structure's kind of built out some sort of framing there. And so next we want to add our members. So adding members you can add through the same way, through the left menu where I can just specify the node ID, so 5 to 7. And you can see that locator is making it a little bit more obvious where these nodes are. So you can enter in that way. Otherwise you can just click and drag between these nodes to add in the different members once you've got your nodes built. And much like the nodes, you can also use the data sheet. It does have its own data sheet as well, so if you want to copy and paste from there, you can. And then we also have a really great pen tool that's designed to speed up this process by not having to build nodes and members individually. You can actually snap to the global grids. So for instance, if I want to extend this structure out, I can sort of hover over node 3 and just pull out along that Z global axis, and it's going to detect that I'm moving along a certain axis and automatically align with that. So it is really quite helpful when you're really mapping out the dimensions of the structure, and you can see here it's picked up an adjacent node at node 6, which makes that process a lot faster and easier to work with. So I'm just going to hover over, and you can also join between nodes as well. So you don't have to create new nodes, you can also just use this to connect existing nodes. Okay, and with our member settings as well, we do have a, I'm going to turn off that pen tool now. With our member settings, we do have a range of different options available and attributes for our members. So I'm going to just mass edit these members here. So I've just highlighted a batch of them, and I can see it's recognized that there's more than one highlighted, and I have a fair few different attributes that I can change for these particular sections. So I can change them to a different section ID so they're different to the members, the columns here. So I've changed that to section ID. I've also got controls so that our members are able to do continuous members, compression only, tension only, cable analysis as well, so you can run a P-delta cable analysis on our members, rigid links, and even joists. So it's quite versatile in the types of members that the software can take. And you can also control your fixities here, so if you want to make the end fixities, whether they're fixed or you can make them pinned, you can control that via the node fixities just by toggling on custom and changing this, or you can hit frame and it would automatically detect them as being pinned. Something worth stating is if you do have questions along the way regarding these inputs, you can hover over these eyes. We try to put these info tips throughout the entire software where they give you a little bit more information about a particular feature. And in many cases, you can actually click them and they'll take you through to the relevant documentation on that particular feature. So it just helps you finding your way along the software if you know that you can click through to our documentation where we have video tutorials and step-by-step guides on how to use particular features or functions. And you can always just click out and continue your workflow. So it doesn't really disrupt your workflow. We try to complement it with by giving you the information you need along the way. And you can also access this in the documentation under help as well in the same way. The module will sort of pop up and allow you to search and browse through our documentation. Okay, so we're sort of seeing the structure start to take shape. You can add plates as well just by clicking plates, and you can either enter in the nodes manually through the datasheet or through this side form, or you can click between the nodes themselves, which is a lot more interactive, and then double click when you close out. That'll finalize the plate. And it's not limited to 3 or 4 nodes. You can build plates of multiple nodes, up to 20 nodes for more complex plates, and then you can always mesh them just by right clicking and hitting mesh. You can do sort of an automatic mesh just by hitting quadrilateral and control the different granularity, or you can put in more specific divisions there. And if you're not happy with your mesh, you can always unmesh and remesh. So it maintains the plate information there, so that you can always come back and edit it as you need. Right, so some other functions and features that help with the modeling process is I can duplicate or repeat my structure as well. So I'm just going to hit Control A, and I can go in my my operations menu and see my different operations, or I can right click the structure, and this will allow me to duplicate my structure up in the Y or any other direction that I wish. And I'm going to choose not to repeat anything else, just the structure itself, and you can see that the structure is then built up. You can also see that I've got a little bit of an error here where my nodes are detected. I think when I was using the pen tool, I went a little bit beyond the snapping base, but I can right click that, and I've got this great merge node functionality that will just clean up my model as I need to. So there's definitely a lot of right-click functionality that makes input of your model a lot quicker and a lot easier. So making the most and just becoming familiar with those features is very, very useful part of the modeling process. For instance, one I use a lot is the split member. So you can split members by percentages or by lengths or by intersecting nodes or members. That's a very, very useful feature that allows me to model a lot faster. And just on that note as well, with selection and sort of graphical controls, I can hold control and select, and if I go one way, so if I go to the right, anything in contact with the box will highlight. So I can see members 33 and 35 are being highlighted there. Alternatively, I can go the opposite direction, and that will just highlight any elements that are strictly within the bounding box of my selection tool. So if I want to move that right wall, I can use that selection tool, and then I can either go to nodes to then move the Z position to say something like -6. I'll confirm that, which will open it up. Or I can also use the relative tool member where I hit R, and I can just shift my nodes just by some XYZ component. So 0, 0, 0, -2 in the Z, something like that. So I've got multiple features and functions that I can use to speed up the process via shortcuts, and you can always go to S3D shortcuts and tips. That'll give me a full summary of all the different shortcuts that I can use with my mouse or my keys to speed up the process. Okay, so I'm just going to continue with the modeling. So next, I'm sort of just working my way down this list. I'm going to add some supports, so some boundary conditions. Again, I'm going to use a highlighting selecting tool, and then highlight the nodes I want to apply my supports at. And I can just double click here, and that's going to pull in all the highlighted nodes into that node input box, and then simply hit apply. So I can apply supports really quickly using the mouse interactions. So materials are sort of preset, but you can add in your own materials, but right now I'm just using structural steel. And then now we've got two sections. So we've got the green beams and we've got the black columns. So what we'd like to do is assign those section properties via our section builder. So I can just click it, the legend here, and it will open up my section parameters. And I can either go through the builder, or I can quickly just search a library of sections. So for instance, W12, pick the section that I want and hit submit. So that's a fast and easy way that we can assign. It's just an automatic save prompt. Easy way for us to assign shapes there. And then I can do the same with this, or I can actually go into our fully functional section builder, where I can create built-up shapes. I can import from DXF or add my own custom shapes, or it uses FEA, so you can really build some very complicated cross sections here. But for now, I'm just going to use the search functionality again to load in something like an HSS shape, or I could do AISI or NDS for wood. Very comprehensive library. But let's do a square HSS and submit that as being our section ID 2. So you can see that's updated there. Right, so now that our model's really pretty much complete, it's sometimes a good time to check the 3D renderer, just to review the section sizes and the dimensions to make sure that what we built makes sense, and pick up any unit issues that we might have added, or any issues with our cross-section properties. But that all looks pretty good. So I'm going to apply some loads. So you can apply all the typical loads, such as point loads, moments. You can apply them at nodes or along a member. Alternatively, you can add distributed loads as well, and you can add in multiple members if you want to edit them at the same time or add them at the same time. You can see they're both highlighted to help identify where those forces are going. And then I'm just going to enter in my Y magnitude, and I'll give this load group a name. So I'm just going to call this live loads. Now I can call this whatever I wish, but it's just going to help me identify and apply my load combinations a little later. So that's some distributed loads. We've really got quite very powerful area load functionality as well, so you can apply one-way, two-way, column wind loads and open structure loads as well. So these make that process a lot easier. I'm just going to toggle off my plates and I'll need my nodes, but I'll toggle off my plates just so to make this a little clearer as I'm applying them. Now actually I might just delete the plate completely, just this one, just so it's a little clearer as we're entering in the plates. So I want to apply an area load to this top surface. Now you can add, so I'm just going to add the corner nodes in a clockwise direction. So 256, 258, 259, 257, and the pressure magnitude of 0.1, and that's going to be in the global y-axis. And this is going to give me the direction of my beam. So I want to go 256 to 257. And what that'll do is pick up any internal members as well. So here's the global pressure. But if I hit equivalent area loads, I can actually see how the loads are being applied to the members. And I also have this great little variance check to make sure that my loads have been applied correctly. So it's just a second set of eyes that shows that it's confirming the internal pressures are being applied correctly. I can also do this to two-way, so I can simply toggle that to two-way. Now two-way, if you want to pick up internal members, you do need to switch on this setting in area loads, and that'll pick up any internal loads. And the area loads will auto update if you move the model. So if I sort of adjust anything in my structure, like shift all these members over as I did before, it'll auto adjust and auto calibrate and calculate the distributed loads on those members based on the area load that you've provided. And again, I'll give this a different name. I'll call this dead load, and we'll see where they come into play when we go to generate our load combinations. And we've also got a great load generator as well. So this will actually pull out the wind speeds based out of a map. So you can just put in a site location, pick your design code, and it'll give you the wind speeds, the wind design pressures, and also help you apply those design pressures to your structure based on these load combinations. And we do follow those we do have a video for that in our documentation. So if you want to learn more about that, search wind loads in our documentation for that video. But for now, let's apply some load combinations. So I'm just going to go to our design code and import some from ASCE 710. And I'm just going to assign the load cases I gave to the load combination, the load cases that are defined in the specific design code. So I'm just saying what I called as a dead load is a dead load in the design code itself. And I'll import those. So now I can review my load combinations. I can also add more if I wanted to here as well, so changing my factors if I want to put in some custom load combinations as well. But for now, I've built my structure, so I've started with the nodes, defined all my members, added some section properties, some support, so the structure is now restrained enough. I've put some loads on it, and I'm now ready to solve. So once I've got my model built, it's actually a great opportunity to then save my file. So to save it, simply visit File, Save As, and you can enter in a file name, and this will go into your cloud storage. So you can come back and access these models or these files from whatever device you're on. So if I'm working from the office and I save as, I can then go to my home computer, and all my files and folders will still be there because they're stored online. So I'm just going to save it as onboarding demo. I already have a model of that name, but I'll just save over it. And the great thing with being on the cloud as well is that we've also, if you're working collaboratively with another team member, you can invite them and share the file with them. So much like a Google Drive document, you can share this with other engineers on SkyCiv, or in your team or in your organization, and you can either send them a copy or invite them to share collaboratively, where they can edit the model and share with other engineers as well. So once I hit submit, I'll see that now that model is shared with Paul, and he will get a notification via email, and he will now be able to edit and work on this model as well. And throughout that process, we keep a clear track of all the changes. So for instance, if I was to add some bracing on this top floor, oops, connect to the nodes there. So if I've added some bracing and I Control S to save that again, it'll ask me to add some comments. So added bracing on second floor. And what that does is it keeps this nice clean history of my model. So I can see that the model was added to or changed here by myself, and also what comments. So added bracing on the second floor. I can see that two members have been added, and I can compare that to a previous model that, say, didn't have the bracing there. So I can actually compare different models or different versions of the model, and even restore previous models. If I want to revert back to an old file, I can easily do that, but I have this clear history of changes made by my team. And this helps if you're going back, if a design changed for some reason, you can actually go back into the revision history to see why that changed and who changed it. And it also ensures that everybody's operating and working from the most up-to-date model. So we've got this clear sort of source of truth in this one model, is the single file that everybody is working from. So I don't have to file like save as, project name _ date and share that with someone, or I don't have to request the most up-to-date version from anyone. We're always working from the most up-to-date version, but we also have the clear tracked history of all the changes made to the model. And another great thing with having the cloud, your files stored on the cloud, is that from a support perspective, as a professional user, you can open up this live chat, and we can see your models in real time. So we can assist you much more quickly because we can see your models, and we can help you identify any issues or troubleshoot the model for as to why it's not solving, or help you along the way. If you have any questions, we can do that a lot faster because we have access to your most up-to-date version, and we can see it in real time and help you with that. So that's a bit about the file storage. You can visit those files at any time by visiting your dashboard. They're broken up into the different software, and you can share, copy, move, or organize them with folders as well, all from the dashboard. Once our structure is built, we should have it that it's adequately restrained. We should have applied some loads and given our members some section properties. But once we've done all that, we're now ready to solve the structure using our FEM solver. So to do that, I just go under the solve button here, and I've got a few different options when it comes to solving. So I've got linear static, buckling analysis, non-linear p-delta analysis, as well as some dynamic frequency and response spectrum analysis as well. So for today, I'm just going to run a linear static analysis. And that'll solve my structure based on all the different load combinations that I specified earlier. So I can see that they're all showing here on the left drop down. So I've got all my load combinations, as well as some envelope cases too. So these will take the absolute maximum of, or the worst case scenario of all these different results, and compile them into one easy, clean set of results that I can review. So we can make our way down the list here. So we've got reactions, where I can see the reactions at the supports, and I can toggle these on and off if I want to change the different visibility settings in terms of those results. I've got shear force diagram, bending moment diagram, and anywhere where you see these blue results, you can click to isolate members, or you can click and highlight. So we've given a few features to help improve the visibility of these results. You can also click and drag to move different labels if you want to see them more clearly. And you can also scale the loads too. So if I just hold S and scroll my mouse, I can see that is then scaling, or I can use this right toggle as well. So I've got axial force, all your typical analysis results like torsion, stresses as well, and displacements too. So I can again toggle and see how my structure is displacing. Have buckling analysis as well. I didn't run a buckling check on this one, but it would just show whether any of your members are buckling and which ones, as well as their buckling shape as well, and frequency analysis. We do cover these in different videos in the documentation video, so if you'd like for a further tutorial on these, feel free to visit our documentation. And finally, we also have some PDF reporting capabilities, so you can toggle on different load combinations as you need them, and you can really build out a custom report. For instance, if you're taking any screenshots throughout the report, they'll display here and you can include them on your report. You can also isolate single member reports as well, so if I want to do a deeper dive on a particular member, I can include a single member report. And then I've got full control over how detailed or summarized I want my report to be. And when I'm ready, I just hit create report. And when that's ready, it'll also give me a summary of my report as well, so I can just view all the different parts of my structure, so I can see the job setup, so I can use this to review and make sure that my structure's been built correctly, bill of materials, and here's my single member report as well, so I've isolated a particular member, and it's giving me my BMDs, SFDs and deflection curves, and then a lot more granular information about evaluation points. And I can download it as PDF if I'd like to export that report and send it off to the client, or have another engineer review it. That can all be done from here. You can also review your results in the 3D renderer, so you can turn on deflection and also some form of member results into color coordinated results, so I can easily identify critical areas of my design. So I've modeled my structure, I've run the analysis, now I'm ready to design the various elements of my structure. So I can do that by going under design, and now Structural 3D is fully integrated with all of our design modules, and you have access to these under our professional account. So we do have member design for steel, wood, cold form, steel. We have connection design for steel, and reinforced concrete design for ACI and CSA, Eurocode and Australian standards. For today, we're going to just focus mainly on member design, and I built these sections all out of steel, so I'm going to use AISC 360, but we do have quite a long list of different design codes that you can choose from, including wood, cold formed, and steel from US, Europe, Australia and Canada. So I'm just going to run AISC 360 16. And what that's going to do is import all my forces, my internal member forces, and parameters for the members as well. But I can control these to change things like my my unbraced length. But all the forces, all the member information, all the material information is all pulled in. So I'm ready to just run a check as per AISC 360. And that's going to give me the utility ratios of all the different members. I can also filter these, so if there's any failed members, I could filter them by failed members or passing members or different shapes as well. So I can just look at my HSS shapes. And another thing we've really tried to do with all of our design modules is open up the black box of existing software. So you can open up a report, so a detailed design report for any of the members which really goes through detailed calculation checks and shows all the different references, all the assumptions, all the values in these incremental steps when we're designing these elements and where these utility ratios came from. So this really helps for you to understand where these design checks have come from and the process we're using to calculate these utility ratios, so you can make a more informed decision of your designs. Otherwise, you can get a design report which simply states the utility ratios of all the various members in your structure. So we do have this integrated, this same integration with RC design as well. So you do have the same capabilities as this, but you can design your reinforced concrete, and we do follow that. We do have videos for those modules outside of this particular video in our documentation for connection design and reinforced concrete design as well. So feel free to check those out via our documentation. Now you can see that all of our sections have passed, and actually quite a low utility ratio of a 0.15. So we can see the structure is definitely over-engineered and over-designed. Now what we can do is use our optimizer to scan through all the different sections that we're using to find a more optimal design for this particular structure. So we do have some settings for the optimizer, so you can control section height limits and widths, and you can also control what utility ratio you'd like to aim for, so maybe a 0.95 as a maximum utility ratio, and as well as which sections you'd like to optimize, so we're optimizing both the sections that we're using in this particular model. So once I'm happy with those settings, I can save them and run the optimizer. And so that's run through all the different HSS and W shapes that we have available, and picked out the most optimized section, and I can see our utility ratio, so I can see they're all passing. And I can also visit the iterations to see all the iterations that were run and what utility ratio each of these sections produced. So I can also rank them by minimum cross-section area. So I can see that is in fact the lightest section of our library. Or I can rank them by utility ratio to find what the maximum utility ratio of all the sections are. So I can use this to look through and just make sure that the optimizer ran correctly, and also if there's any other section that I'd prefer to use, I can pick them out of this table as well. But for this particular case, the optimizer that was selected was the correct one at W6 by 8.5. And likewise, that was done in our HSS as well with a utility ratio of 0.824. So I can go ahead and commit these sections. So now that I've committed those sections, I can then rerun my check and should find a more optimized design with high utility ratios. But it obviously makes the utility ratios are still quite low. We didn't apply much of a load to the structure, so those values kind of make sense. If I'd put more loads in, I'd probably see a utility ratio higher to that 0.9 that I was searching for in my optimizer settings. So great, I can go ahead and save that model now. Again, making comments, so ran optimizer on W and HSS shapes. So again, I'm keeping that clear track record of all the changes I'm making to my model for team collaboration.